watershed restoration plan with you all, specifically focusing on addressing aquatic barriers. Before we jump in, we just wanted to do some quick introductions of ourselves. So I'm Amber Siegel. I'm the Senior Restoration Manager here at the Charles River Watershed Association. I will bump it to Lisa.
Hi, all. I'm Lisa Kumpf. I am the River Restoration Director at CRWA, and I'll bump it to Amelia.
And hello, everyone. My name is Amelia Dick Fiordel Fabro, and I am the Senior Restoration Associate at the Charles River Watershed Association.
All right, so our collective team in the restoration program has gone through a lengthy process of method development and data collection for this plan, which, as I mentioned, focuses on aquatic barriers specifically. Those include dams and culverts, which are our focus because they are extremely impactful on the health of our river, and we will get into more details as to why shortly. The ultimate hope for this plan is that the results showcased will help direct our work moving forward as we look to identify areas for restoration projects in the coming years. Next slide. So a quick overview of what we'll speak about today. We'll have a brief introduction, a quick methodology, then we'll get into the results by category, case studies, some next steps, and questions. So if you do have questions during, we ask that you keep them to the end or chat them during, and we'll keep track of them and respond after the presentation. Next slide. So to start out, we would like to humbly recognize the Massachusetts, Wampanoag, and Nipmuc nations as the original stewards of the land on which we work and honor their enduring role as caretakers of this territory. We would also like to take this time to share that we did consider and try to factor in Indigenous perspectives into this report. It is something that is difficult to quantify in terms of some of our analysis processes, but we did talk to our Indigenous partners during this development process to ensure we were accurately considering their perspectives and concerns, and you will see some of their perspectives centered throughout the plan via quotes and other elements. So to give a quick background on our organization, we are the Charles River Watershed Organization. As many of you may be aware, our mission is to protect, restore, and enhance the Charles River and its watershed through science, advocacy, and the law. Some additional background. The Charles River, or the Quinnipiac, which means a river that runs back on itself, flows for 80 miles from Hopkinton to Boston Harbor. It spans 35 cities and towns across 308 square miles. A new statistic, I guess that we're excited to share is there's 544 miles of streams or tributary length in addition to the main stem. And so part of the hope of this watershed plan is that it's taking our focus beyond the main stem into those tributary miles, which are very impactful on the health of our watershed. So in total, then, we were looking at 624 miles of river and stream together. Over the past 400 years, however, these waterways have really been fragmented, and that began with colonization. And this resulted in poor water quality, impeded fish passage, habitat loss, invasive plant growth, and health and safety risks to people. So those are some of the issues we're hoping to address and potentially rectify through these restoration projects that we identified. Next slide. So now we're going to get into a little background for the plan itself. As I mentioned, the hope for this plan is to direct our work in a manner that addresses the issues caused by the watershed's fragmentation. We're hoping to restore biodiversity, ecosystem health, and mitigate flooding, while also acknowledging the rights of present-day Indigenous people. So I'm going to hand it off to Lisa to do some context setting.
Thanks, Amber. So we have a little just kind of educational diagram here. And what we're really wanting to do with this is, frame in people's mind what river restoration is. And when we take into account restoring a river, even in an urban context that our watershed sits in, we have to think about all of the different elements of an ecosystem, an aquatic ecosystem, and that really includes both living and non-living parts. So you can see some of those really highlighted in this diagram. When we think about river restoration, a lot of times the first thing people tend to think of is the fish and the connectivity of those moving up and downstream. And right now we're in the middle of our our exciting herring migration of the spring. And that's, of course, really important. But when we're fully restoring rivers, we need to think about all of those other elements as well. And that includes, the running water, the birds in the sky, the aquatic mammals that there are, the plankton and the benthic macroinvertebrates that live in the sediment and the sediment itself. So we wanted to really make sure that when we're prioritizing projects for restoration, we're taking into account the full ecosystem. But of course, people are really interested in the fish, and so are we. So we did want to highlight a few of the really exciting fish species that we have in the Charles River. There are 25 known fish species in the Charles, and these are just some of them pulled out here and kind of sorted into the diadromous or migratory fish species, the freshwater fish species, and then we do have some cold water fish species as well. And I love this quote by our Indigenous partner, Hartman Dietz, who says, in the old times, they said the rivers would run black with herring, that you could walk across the rivers on the back of the fish. And that's not true anymore. And I think that really highlights the abundance that our rivers, including the Charles, used to have in the old days and what we're hoping to restore the ecosystem to in the future again. And I'll hand it back to Amber.
Thank you. So to just give a little more color to what dams are and the issues that they are causing, we are defining dams, or dams are defined as walls in rivers that are often made of concrete, stone, or earth that hold back water, creating an impoundment or the pool of water that you see behind them. In New England, many of these dams were originally built for power generation for things like sawmills or grist mills, but this was back in colonial times, and many of those dams are no longer serving that purpose or, in fact, any active purpose. So we are exploring the question, why not remove them if they are not serving a purpose? Some of the issues that dams cause, as you can see in this diagram, is stagnant water in the impoundment behind, and that stagnant water can result in lower oxygen levels and higher temperatures that can cause death of aquatic life, so fish, also cyanobacterial blooms and invasive plant growth. In front of the dam, we see obviously rushing water causing erosion. It also is a full blockage of fish trying to go upstream to spawn. And as we see at places like Watertown Dam, we do have a fish ladder that can be effective for some species like herring. Others like shad struggle with the fish ladder. So that dam can really inhibit the well-being of fish and other aquatic animals in our rivers. So what would the benefits of removal be? It would reverse a lot of these issues, and quite quickly. So if we remove the dam, oxygen levels may increase, temperatures will decrease, invasive plant growth might decrease, and the riverway is open for those fish to swim up to spawn, also open for recreation for those living around the river. So next slide. Just wanted to give you a quick sense too of how quick this restoration of the river can occur. So this is a before and after of a dam on Sucker Brook in Pepperell, Massachusetts, and this is just 1 year difference. So the before shows the dam. Within a year of it coming down, you see those natural banks and native plants regrowing. The stream obviously shrinks, but it's still there and it's still flowing, and it is open for the animals that would like to use it. We have another Hartman Dietz quote here that we think quite beautifully portrays the issue that dams are causing. Rivers are like the arteries of the earth. They're like the blood flow. If you dam a river, it's like clogging an artery. When you see a blockage, that is not how rivers are meant to be. And then I will pass it to Amelia to speak about another kind of barrier.
So the other barrier that we explored were culverts. And a culvert is a structure that allows water to pass under a road, railway, trail, or driveway. So some sort of tube, bridge, or other crossing that allows the stream to pass underneath an existing roadway. They come in a variety of shapes and sizes, and they range from really small pipes that allow a small tributary to go underneath them to large bridges. And they can be made of plastic, metal, stone, or concrete. Now, the problem that culverts pose is, unlike a dam, they are not completely stopping the flow of water until it overtops. but they can cause some impoundment of water. So oftentimes these culverts are not sized correctly for the stream channel. And it creates a pinching as the water is trying to move through the channel. What that does is it impounds water behind the culvert, and it can lead to roadway safety issues like flooding. It can degrade the actual structure itself, chipping away at the concrete, corroding the metal faster, causing roadway safety problems, and it also causes ecosystem fragmentation. So sometimes those culverts are actually perched too high above that existing stream channel. They have some sort of grate in front of them, or even a large amount of brush and debris gets trapped trying to move through the channel because it's so small, and it becomes a barrier to fish passage. In addition, culverts are actually supposed to be, according to the Massachusetts stream crossing standards, 1.2 times the active width of the channel. And what that does is it actually allows for the channel to grow and contract as the season progresses, but it also generally provides dry passage on either side of the culvert. And that dry passage provides a terrestrial land bridge for terrestrial animals to cross without actually needing to cross the roadway. When we have that, it minimizes road strikes. And when we don't, we're seeing a barrier for both aquatic and terrestrial species. So when we're assessing our culverts, we go out and we do a NAC protocol. So that's the North Atlantic Aquatic Connectivity Collaborative. And that assessment is primarily focused on aquatic passage for fish. So our method for this is really think like a fish when we're out in the field. Could a fish get through this? Is this going to be a barrier to our aquatic life? Next slide, please.
Okay, so now we're going to get into our methodology. This will admittedly be a pretty brief overview, but we will have a full detailed methods document on our website that we will share out and that you all can reference. And then, of course, we're happy to answer questions after or directly. Next slide. So our methods for this really came from 5 precedent reports, which again are featured in our full methods document. We reviewed these plans from other watershed organizations and state organizations, and also considered what would be most impactful or relevant to our watershed. So from that, we picked out 5 scoring categories and then a series of supporting metrics as well. Before I describe those further, though, I do want to mention that we have quite a few dams and culverts in our watershed. To kind of focus in our work, we decided to only score those that we felt would be most actionable and pressing. So we do have a series of culling methods that again are in that document that show how we removed some dams from the scoring as well as some culverts. For dams, for example, we decided not to score for potential removal those dams that were providing active flood control, that might be providing very valuable public recreation. An example of that could be the new Charles River Dam, which is of course providing a very important flood control service for the residents of Boston. And so we would not recommend removal of that dam. So the scoring categories then that we looked at were dam safety and culvert safety, water quality, community impact, ecosystem condition, and connectivity. We were very intentional about including the community impact category because we noticed in the precedent materials that that was largely omitted. Understandably, a lot of them just looked at ecosystem health and connectivity because, of course, that is hugely impactful by dams and culverts, but we do feel like the community aspect is very important. And yeah, I think we'll get a little more into kind of what those metrics were when we share the results with you. So why don't we just move into those results now? We will be presenting them by category. So the 5 that I listed, you'll see the top results in each category. And then at the end, we will share those projects that emerged across all categories and are really our top restoration projects moving forward.
Great, thanks, Amber. So the first results we're going to show are for dam safety, and we did score the dam safety category and the culvert safety a little bit differently, just based on the assessments that are available. So for dam safety, our metrics were the hazard class of the dam and the condition of the dam. And those are a little bit different, but can be confusing when you're just kind of saying the name sometimes. The condition really refers to the physical structure and how well it's holding up. And the hazard class, which is defined by the Massachusetts Office of Dam Safety, is saying basically what would the potential damage be if there were a breach. So you can have a dam that is in good condition but has high hazard or significant hazard, and that means that it's not necessarily in risk of breach, but if it were to breach, that it could cause damage downstream. So obviously safety is a big concern when we're thinking about dams, and it is currently the way that our state is prioritizing dam removal projects for the most part. And there are funding streams to support dam removal, such as the Dam and Seawall Grant. So this is obviously something that we wanted to look at and see how our dams in our watershed scored. And you can see here, for example, this is actually the North Bellingham Dam, which you can actually see through it in this picture down on the left near those trees. It's in very poor condition, but it is a low hazard class dam. And it actually is not in our results because it's almost kind of crumbling as it is in this case. You also can see that our top scoring dam was the South Natick Dam, and that is coming down this summer in 2026. So our scoring kind of made sense for what was really already being prioritized in our watershed. Next slide.
So as Lisa mentioned, we did score culvert safety a little bit differently. And that's simply because there is no official data layer or assessment for the safety or quality of a culvert the way that there is for dams. So in order to do culvert safety, we used the NAC data, and we essentially filtered for two factors. So the first was any dam that was considered to be in poor condition was selected out. And poor condition is a metric that's decided in the field, and it's done based on a basic visual assessment. And we're looking for culverts that are very obviously degraded. So you can see two examples in this photo. We're seeing corroding metal, exposed rebar, crumbling concrete, collapsing in walls. That's what we're looking for something to receive a poor score. And what that means is just based on a visual assessment, we're thinking that a city or town is likely going to have to do some major repair work or replace the culvert in the near future just to maintain its function. And then we selected out culverts that were some form of an aquatic barrier. So that's a moderate, significant, or severe barrier to aquatic passage. And that is what made it onto our safety category for culverts. So essentially, we're selecting culverts that likely already need some work done, and we're saying, hey, these ones can be prioritized because they are also a ecological barrier. And it would be great to, when that work is occurring, prioritize meeting that 1.2 Massachusetts stream crossing standard. Next slide, please.
Great. So moving on to our water quality category, we wanted to focus on water quality since that is a main mission of our organization, and dams and culverts can, as we mentioned earlier, can impound water or create these pools of water behind them, and that further degrades water quality. So for the metrics for this category, we used both the impairment status on the integrated list of waters, which is something that Mass DEP puts out every few years, and took into account whether or not the streams were impaired. And then we also took into account the amount of impervious surfaces or roads and roofs in the kind of sub watersheds of our larger Charles River watershed. And you can see this kind of gray gradation on the map here is showing the percent impervious. And why that's important is because the more impervious percentage you have in a sub watershed, the more stormwater runoff you're going to get into your area. And so the more it's kind of a proxy for the degradation of the water in that watershed itself. So taking into account those two factors, we were able to rank some of the top dams and culverts. And you can see here that some of the ones that came up are really focused in our lower and our upper watersheds. Watertown Dam is one that we're actively advocating for the removal of. Duck and Mill Pond dams came up highly, as well as Cheesecake Brook culverts, which are which are new and close to the lower watershed, and then a few dams and culverts in our upper watershed as well. And we have a full table of our highly scoring ones in our full watershed restoration plan, but didn't put it on the slide here, so you can take a look there for a more detailed list too. Oh, I also wanted to point out in this category, Sanford Mill Dam scored highly, and that's one that the town of Medway has been actively looking at through an alternatives analysis. So that's another one that I wanted to highlight there. Next slide.
All right, so now we'll move on to community impact. As is known, EJ communities are disproportionately impacted by climate change and are underserved in terms of restoration and climate resilience efforts. As we mentioned, a majority of the precedents did not address the social component, so we tried to be intentional in doing so. Additionally, our watershed does have a high percentage of environmental justice designated neighborhoods according to the state. So when considering what metrics to use, we looked at EJ blocks and whether the structure was either within that EJ community or proximal to the EJ community. And then also the 20, 70, 100-year flood layer from the Charles River flood model so that we could consider and prepare for extreme flood events in the future, specifically within these EJ communities that are not always being given appropriate preparation and mitigation for these climate events. So as you can see on our map, most of the results were in, again, the lower basin. All of the dams actually scored 100%, meaning that they were within environmental justice neighborhoods and high flood risk areas. Again, Watertown Dam does show up there, which of course we are advocating for the removal of, as Lisa just mentioned. And then both of the brooks are actually located in Waltham, which we found interesting. So these will definitely be areas that would direct our focus in the future, especially if we are looking for areas in which to support community and mitigate some of these climate impacts. Next slide.
In addition, we also scored ecosystem condition. This was a very important category, especially for culverts. And to do this, we focused our attention on structures that are located in multiple types of priority habitats as identified by the Massachusetts biomap. So we put a particular focus on cold water resource streams. So these are spawning habitats for cold water fish, and they have to maintain a consistently cold temperature of around 68 degrees Fahrenheit in order for them to be a cold water habitat. There are only 9 of these habitats in our entire watershed, and they are continually being threatened by increased temperatures due to climate change. It's very important that we do everything in our power to preserve them. Additionally, we focused on androgynous fish habitat. These are fish that migrate from the ocean to spawn in fresh water. And we also looked at some native population habitats, but did not give this as highly a consideration as we did to the migratory and cold water fish who tend to be lacking in habitat. So for culverts, Trout Brook, very apt name, right? And Stony Brook rose to the top of this list. These are both cold water fisheries and therefore placed very highly. And it would be very impactful for us to do work along these 2 streams in the future because they present such an important and delicate ecosystem. Next slide, please.
To wrap up our 5 categories, and we have connectivity, which is of course a major reason for doing this restoration plan, especially on a watershed scale. As we discussed, both dams and culverts can provide barriers to connectivity. And that's for both animals and also recreators. And a lot of people like to recreate throughout our watershed. And aside, there is funding for this work right now through NOAA and DER, so it is a very apt time to be looking at this sort of work. To reiterate as well, dams really entirely eliminate connectivity. It's really a difficult workaround. There really isn't going to be a good scoring dam on connectivity because it is blocking the entire span of the river. While we do know some of these dams have fish ladders, we of course think dam removal is much more effective. While we support fish ladders where dam removal is not possible, they really aren't as effective as we would like them to be. For example, at Watertown Dam, there is a fish ladder. Herring are doing okay at making it up it. Shad, much less so. They are not as good at finding it or making it up that ladder. So it is not supporting both our anadromous and native fish equally. So again, we would think that dam removal is more effective for connectivity for fish. And also our recreators, it would be easier for them. As Amelia mentioned, culverts may or may not inhibit connectivity. A properly sized culvert may be okay. A poorly sized culvert or a perched culvert is going to be a problem for connectivity. Given the differences that dams and culverts pose to connectivity, then the methods are a little bit different. For dams, we really looked at potential distance gained between. So if we had a dam we were looking at and that were to be removed, how much open riverway would be between the most upstream and downstream dams, and we took that distance. We also considered the proximity of the structure to the lower basin or the harbor, as open ocean to river is key for the anadromous fish that are migrating upstream to spawn. For culverts, we looked more at the aquatic passability index, so the ranking of passability or lack thereof through NAC, because again, culverts may or may not be passable. So taking those elements together, you see our results displayed here on the map. South Natick emerged as a top priority. Excitingly, it is slated to come down this summer, and South Natick will open the single longest stretch of main stem river on the Charles. So we're really hoping that builds some momentum. Again, we see Watertown Dam. Although it may not open the longest stretch, its location as first dam after the new Charles River Dam means that it's going to be very impactful to those anadromous fish trying to migrate upstream to spawn. So again, a priority. For culverts, again, you see Cheesecake Brook and Cherry Brook, all located in mid to lower watershed. And again, this is just going to help direct our focus as we look to what sorts of projects to work on when we have connectivity in mind. Next slide. All right, so then taken together across all 5 of those categories, we come to our top aquatic barrier removal sites. The dams included scored highly in minimum 2 categories and as much as 4 categories, as was the case in Sanford Mill Pond Dam. The culverts either had multiple culverts on a specific stream or across multiple categories. So we might have a culvert or a stream that has 3 culverts coming up in connectivity, or a stream that has different culverts coming up across each of the 5 categories we discussed. Ultimately, we ended up with 9 dams and 11 streams and over 30 culverts. So the map on the right really showcases those top sites. You'll see Watertown Dam, you'll see South Natick Dam, Sanford Mill Pond Dam, all of which have active work going on around them. And then Beaver Brook, Chester Brook, Stony Brook, which had the highest number of culverts on them. Stony Brook being a cold water stream is, of course, of particular interest. So these are the top projects that we will have in mind as we move forward in the coming years. Next, we will share a case study example of what this work could look like.
Great. So we've got a few case studies of work that's already going on and some momentum that's building for both these dam removal and culvert replacement projects. First, as we've mentioned a few times in South Natick, that dam is slated to be removed this summer in 2026. And it scored highly in 3 of these categories: safety, ecosystem conditions, and connectivity. We also think this dam removal process is a really great example of community engagement. They went through a 2-year process of having a committee dedicated to considering all aspects of potential dam removal or replacement, which they were originally considering. And one thing that I think we really swayed folks in town was the Indigenous perspective. Kristen Wyman is a Nipmuc person who lives close by, and she did present to the Dam Advisory Committee as they were considering the alternatives. And her speaking really allowed folks to think about the longer term history of the river, before the last 400 years when a lot of these dams were put in place. And she spoke to that, seeing the dams in the river on a daily basis is actually a reminder of the oppression that her people have gone through. And so removing these dams can not only be, an ecosystem focused thing, a community focused thing, but also a reparation or repair of that relationship that people have with nature in our river. Another great example of work that's ongoing is several culverts on Stony Brook, one of those cold water fishery resources in our watershed, is ongoing. Both the towns of Lincoln and Weston have really moved forward with 5 different culverts along the stream stretch, getting several different iterations of Division of Ecological Restoration culvert replacement grants. And while no active construction has happened yet, those 5 culverts are in various stages of planning and engineering and permitting to be replaced in the future. So that's really exciting work and on one of these priority streams. So we hope this really supports that cold water fishery habitat and maintaining a healthy connectivity, water quality, etc., for the species that live there. Next slide.
In addition to these opportunities, we also want to highlight some other types of restoration opportunities that we would like to consider. So when we originally took on this plan, our goal was to look at the most impactful opportunities at a broad scale. And this really boiled down to dam removal and culvert replacement because that's where a lot of the funding is currently. But there's lots of other localized projects that we can do to really impact our water quality and enhance ecosystems. So those can be anything from bank naturalization, daylighting an underground stream, putting fish ladders on dams that do not currently have one and cannot be removed for flood control reasons, or restoring wetlands and conserving lands. Additionally, daylighting those buried streams, that's one of our most impactful opportunities, but they also pose a special challenge. We have lots of buried streams throughout our watershed because it is so urbanized. And these are often very inaccessible and very culturally inaccessible. People do not know that these streams exist and they're unaware. So highlighting those culturally and also physically daylighting them can be a really excellent way to improve our water quality. When we were initially doing our culvert prioritization, we actually removed culverts that were considered buried streams. And we did this because there's no funding pathway the way that a traditional replacement is funded. But a lot of those culverts in those buried streams categories did score very highly for poor water quality. So some examples of other types of work that we do to actively restore our ecosystems are, for example, we are doing a wetland restoration in Mattapan of Canterbury Brook. Canterbury Brook is the only daylit portion of a larger underground tributary of the Charles called Stony Brook. And we are working with the City of Boston and the Mass Audubon's Nature Center to actually reconnect this very channelized system to an existing wetland and create a stormwater feature that will actively prevent flooding while also enhancing the ecosystem. So this is just one example of some of the additional work we do to restore our urban tributaries. Next slide, please. Now that we've talked
Amelia.
about all of these opportunities, I'm going to hand it off to Lisa to just talk about our actionable next steps to move this forward.
Thanks, Amelia. Next slide. So overall, this is kind of another summary slide of those really top restoration opportunities for dams and culverts that have been identified as part of this plan, again, including 9 dams and 11 streams with over 30 culverts that scored highly in these categories. And we wanted here to really summarize these by municipality and by town, just to make it a little bit more actionable, because folks can get involved in what's going on within their own communities. And, as we've highlighted through this presentation, there is ongoing work in several of these towns already: Newton, Watertown, Dover, Medway, Natick, Weston, Lincoln. So really we want to hope this can build some momentum towards these projects going forward. Next slide. And as kind of our final plea, we want all of you as supporters of CRWA and of restoring the river to take action, to advocate, engage, and volunteer. One of the biggest things that folks can do is just share your knowledge. The more people understand about these pretty technical things, dams and culverts, the more they'll become aware that, first of all, that they exist. A lot of people, don't think about culverts as they drive over roads and streams all the time. But then thinking about the problems that come with them, making people more aware is really helpful. And we hope that this can keep the conversation going, especially at a local level, when your town conservation commission or your city councilors or town select board might have a lot of power to prioritize some of these issues and help adapt your town to climate change and reduce flooding, etc. These can be really impactful projects for that. Another way to take action is to make a gift. CRWA helps out a lot with making sure these projects keep moving forward. And a lot of what we do is support towns. And we don't get any money through the grants that we often spend time coordinating and writing. We do a lot of education. Again, lots of grant applications, and we rely on individual donations in order to make that work happen and continue it forward and work with as many municipalities as possible. And we really have the power to make this river what we want to have it be. And it's really time to take down some of these barriers, physical barriers in the river. And we can really do this together at a local level. So I encourage you all to use your voice and talk with your friends and neighbors and town members to just get the word out there about all of these issues. Next slide.
Yeah, so in closing, we just want to thank everyone for coming out today to listen, as well as everyone who contributed to this report. It was a huge group effort. Some of the folks we'd like to acknowledge are the Charles River Climate Compact and just all the municipalities that had dams and culverts listed who gave us feedback on those sites. Hartman Dietz and Kristen Wyman, our Indigenous partner and support in this, the Mass ECAN Peer Learning Program, Scott Jackson of UMass Amherst, who was helpful in helping create some of those impervious layers you saw us use in GIS for water quality, Julie Richberg of the trustees. Many of our interns helped contribute to this GIS work, as well as Anonymous Foundation. So we look forward to continue sharing this research across our watershed and seeing where it can take us in the coming years. And in wrap up, we will now take some questions.
Looks like we have a couple questions in the chat. So I think the first one, Heather asked, is that asphalt or concrete? I think that was about the North Bellingham Dam.
Yeah.
Oh, I believe that's concrete.
Yeah.
Awesome. And then Charlotte says, I'm curious what the status of the Watertown Dam removal is. It seems like this is the most important blocker to achieving CRWA's big goals.
Yeah, it's definitely been something that we've been working on. And as you could see from the report, Watertown Dam scored highly in, I believe, 2 or 3 categories as part of our prioritization. So the current status is that we've been working with DCR over the past 2 years. They've been conducting an alternatives analysis study, and they've presented publicly about this a few times. We have links to those presentations on our website, on our Watertown Dam website. that you can find. And in their last public presentation, the engineers working for DCR recommended full removal for the purpose of ecological restoration. Now, it's ultimately DCR's decision of whether or not to remove the dam. That's the Department of Conservation and Recreation, and they are the dam owners. Right now, they've said that they're really prioritizing, they own several dams throughout the state, and that they are prioritizing dam removal for those ones that are most safety issues. And Watertown Dam does not score highly for safety issues. It is in pretty decent condition, although it is considered a significant hazard dam, which again just means the potential for damage downstream if there were to be a dam breach. So we are really advocating for removal of Watertown Dam on the basis of ecological restoration. And we can see that from our prioritization that it really is a priority statewide, honestly, from an ecological point of view to restore that anadromous fish passage, to restore the water quality and the community impacts in this location. So we definitely think that the state should be prioritizing dam removal for the purpose of ecological restoration. And this is consistent with, for example, the Healy-Driscoll administration's biodiversity goals that they just came out with. That calls for removing 10% of the dams in Massachusetts by 2050. That's 300 dams. And this is focused on restoring biodiversity. And we believe Watertown Dam coming down would do just that.
Awesome. It looks like we have one more in the chat right now. Pamela says, are there any hands-on outdoor volunteer opportunities to help with these projects?
One thing you can do is count fish. We've got a lot of, and maybe Carly, you can drop the link to our fish count. At Watertown Dam, we have a lot of active fish counters at this moment. The last 2 days have actually been crazy for fish coming up the stream. But basically you go out and you just look in the river at the top of the ladder, the fish ladder, and click a clicker for 10 minutes, and you can help contribute to a growing database of data. So hopefully over time, we'll see that there are more and more fish coming through the ladder. And then with removal of the dam, hopefully we see more fish making it upstream as well.
And a couple other ways would be if there's an active dam removal project or culvert replacement in your municipality, you could certainly attend those public meetings. A couple of different municipalities have things upcoming, I believe Sanford Mill, Bellows Pond and Newton. So attending some of those and showing support is always very helpful. Other restoration opportunities we listed, I think, was invasives removal, and there's a lot of great summer volunteer opportunities with us to do invasive plant removal, including water chestnuts if you want to get out on the water. So those are some smaller scale ways, but very impactful still that you could do hands-on volunteering.
Can I also ask about the culvert assessment? I guess it was maybe in the springtime and I maybe missed it, but is there any ongoing, I don't know, way to be involved in that?
Yeah, absolutely. Right now, we're not doing culvert assessments. So we try not to do them in the spring because the water level is a little too high. And then we're just wrapping up some of our grant deadlines. But this late summer and fall, we are going to be considering going back out and doing additional assessments, in which case we will often put out a call to volunteers because, and you would go out with a staff member to do those assessments. And you can even get NAAQS certified if that's an opportunity that you would like to pursue. It just requires a little bit more intensity in the field. It's around 3 full days of field work to get that certification.
And can I start doing the certification now so I'm ready in the fall when you maybe have the call?
You could do the online portion of the certification and then do the field days afterwards. Yeah, absolutely.
Email Amelia about your interest.
Okay.
Yeah, I can set you up in the NAAQS system.
Okay. Thanks.
Of course.
I'll put it to this slide too, in case anyone has any questions. Feel free to contact us at charles@crwa.org. And we're on a bunch of different social media as well. So you can follow us there, DM any questions that come up. And I'm also just going to throw in the chat, our watershed restoration plan is on our website. So I'm just going to put the link in case you want to review it after this presentation as well.
I had some other questions, but I don't know if we've gone beyond time or.
Now we've got some more time, so go ahead and ask them.
Well, I was wondering about the locks at the Science Museum. Like, can fish just go right through there, not knowing that they're getting a little elevator ride, and that's fine, and there's no problem with fish passage at the Science Museum?
Yeah, that's a great question. So there's two dams. The Science Museum is the Old Charles River Dam, and that is breached. There's a channel on the side, so that is considered totally open for fish passage. At the New Charles Dam at the locks, the Division of Marine Fisheries has an agreement with DCR, who operates and owns the locks, that they basically coordinate on making sure that the locks get opened during the herring migration, especially to let fish in. So that is the case at the Amelia Earhart Dam in the Mystic River as well. And so, and there is a fish ladder at the New Charles Dam as well. So that generally fish can get by that in a decent fashion.
So it's kind of, you feel like that's great, or it's just, it is so, but there's nothing more we can do about it?
Yeah, I think there's definitely opportunities to make it better. And I know that the Division of Marine Fisheries is in conversations about that in the long term, but that is an active and very important flood control dam. So it needs to be kind of operated in that context as well.
I guess I was also wondering, I didn't understand what cultural daylighting meant.
Happy to explain that one more. So, cultural daylighting is really something that is used if physical daylighting is not possible. So, in an ideal world, we would be able to re-expose the streams to daylight, to fresh air, but a lot of these underground streams are flowing through Boston, downtown Boston, very densely developed areas. So, properly exposing the stream is just not possible. Alternatively, we think about cultural daylighting, which is basically just educating the public on the fact that there is a stream flowing beneath their feet and what they're doing above it is actually impacting a waterway. So we might use educational signage, or there's sometimes like fun art projects, little murals on the street, things like that, to just let people know that there's still a natural feature there, even if they can't see it.
I was also wondering if, like, is there a way to do like temporary fish ladders, because a full dam removal takes many years to plan and stuff like that? Like, or is that just too dangerous to do a temporary version of it?
I don't know about. Yeah,
yeah.
I'll let you go.
I'm not an expert on fish ladders, but they also take a lot of planning and fundraising. So typically when a fish ladder is put in place, or even like a nature like fishway, which they did in Braintree recently, that takes, a significant amount of engineering, permitting, planning, construction, all of that as well. So putting it in temporarily, I think, is not usually the kind of best cost benefit analysis. That's my understanding.
A temporary option that we have seen are like bucket brigades, so to speak. So people, at Fuller Brook, for example, will just help the fish over the blockade, so to speak. So not really a temporary fish ladder, but perhaps a temporary help or a solution.
So how do I volunteer for something like that? A bucket brigade, for instance.
So there used to be an organized one in the Mystic River that I think is now, there's been a restoration project there. I think a fish ladder was built so that it's actually pretty functional now. The only other one we've known is, again, in Fuller Brook for these white suckerfish, which are residential freshwater fish, but they're migratory as well. And that, I believe, it doesn't have like a strong organization around it. It's a little bit more ad hoc. So those are the only two ones that I'm familiar with.
Fuller
Yeah.
Brook, you said?
In Wellesley.
I was also wondering about if beavers build dams. Like I heard that they partly build dams when they hear water flowing, and so I was wondering about the culvert outlets if the beavers build dams there. Maybe we don't have any beavers in the Charles River Watershed Association.
We definitely have
we do.
beavers.
Oh, okay. Okay.
Lisa or Amelia, you're more well versed in culverts than I, so I don't know if you have any specific experience with beavers at culverts. I was generally going to say we often are asked if we would remove a beaver dam, for example, and our response is typically those are meant to be there. They're porous using, sticks. There's usually little routes that fish and things can get through. So those sorts of dams are working with the river, so to speak. If they're blocking up culverts, though, is a question for Lisa or Amelia.
Yeah, Amelia, do you want to take that or you want me to?
Yeah, absolutely. In terms of culverts, for beavers, sorry, I did just get kicked off the meeting a little bit. My laptop died, but if they are blocking culverts, that can sometimes cause more of a problem for a municipality. It's kind of a human issue because it can lead to the culvert overtopping, which will flood a roadway.
Right.
So what people usually implement is some sort of beaver deceiver. We've seen a lot of those in our watershed, just to keep the beaver from building in that specific choke point so that the road doesn't overtop.
Yeah, it really becomes kind of a maintenance battle sometimes with local municipalities trying to unclog beaver sticks and things like that. So yeah, we do see that those issues pop up.
Cool. Well, it sounds like lots of exciting things. So thank you all.
Thank you for your
Thanks,
questions.
everyone.
Okay. I guess I'll look for Amelia's email on your website.
Great.
Absolutely. Thank you, Pamela.
Thanks.
Awesome. Stop the recording.